And welcome back, ladies and gentlemen. Let's go ahead and jump into our last part of the LC3 now when we talk about building our first program. We've already talked about binary and hex, so now let's look at it with assembly. And so here's our program in assembler. And you can see that it is not binary or hexadecimal, which we are kind of familiar with. This is assembly, or well, this is an assembly language for the LC3. Different assembly languages would have different structures. This is the one for the LC3. Right? And of course, we've already seen this exact same program written using binary and hex. Right? And just as before, let's just look at that with comments on it to see what that looks like. And so here is our original program. And you can see there's an originate line 3000. You can see now here instead of those hex numbers, remember I said each of those hex numbers represents something? And here you can see what those hex numbers actually represent. Because in assembly, we're going to go ahead and just write and, we're going to write add, we're going to write not, we're going to write whatever that opcode is, but we're going to use a more English-based approach. So for some people, hex might be easier, the binary, or the assembly might be easier. It just kind of depends on how you want to approach it. All these are valid ways to do it. All right, let's look at saving that program though, just as we've done before. So we click on the save icon or choose save on the file menu. We save in the same folder we did before. We're going to call it addnums.asm since we typed this in assembly. Then we're going to create the object file. So same as before, we have to convert it to actual binary and save it in a file called addnums.obj. And we're using the editor. We're going to use one and only one of those buttons to make it happen. And we're going to press the ASM button since our code is in assembly. All right. So let's save that file to the same location that we did our binary hexadecimal addnums files. And let's go ahead and take a look at that in demo time. Right, so I'm just going to go ahead and exit out. Head on over to the LC3 editor here. All right, and now that I'm in the editor, I'm going to go ahead and type in my code. All right, and so there's my code, and you can see now that's exactly what we had on the commenting page. Only now instead of binary hex, we now have assembly. So let's go ahead and save that file. And of course, this is addnums. And we're going to do .asm for assembly. Now let's go ahead and click on that ASM button. So I click that. And you can see that it passed with no errors. Important thing I do want to point out is make sure that you have this .originate and .end on your assembly code because it tells the program where you're starting. The .end tells it when it's finishing. Right? Those are a little bit different than maybe what we had to look at with our last few things. Okay. So let's go ahead then and take a look at that on our desktop. And you can see here's my addnums program. I'm just going to go ahead and label that 3. But you can see that rather than just one file, I kind of have a couple more here. I have an addnums.sym and an addnums.lst. Right? And I can actually look at those and see what they are using simply just Notepad. So if I open those up on my desktop, I can actually open up SYM and LST here. And you can see that there's values inside of these files that were generated when I converted that over. So we saw the one and here's the other. Let's just talk about those really quickly here. So start off first with addnums.sym. So after running our assembly program through the converter, we got two files, addnums.sym and addnums.lst. If we opened addnums.sym in the text editor, we saw we had this right here, symbol name, page address, loop 3004. This is a label in our program that the assembler saw was at location 3004. If we had more labels, they would then appear on the page address. So remember, labels are things like loops, are one of the best examples here of a label. Now, they also look at addnums.lst. We opened the text editor and we saw all these different lines of code in here. Now, rather than going through each and every one of the lines of these code, I'm going to examine line 6 here, because that's the one that has our loop label in it. So let's go ahead and analyze that line of code. If we look at that line of code there, you can see it's quite kind of almost complex. Look at 3004, 6680, 011001, 101, 000000, parentheses 6, loop, LDR, R3, R2, #0. Whew, that's a lot. So let's start with the 3004. This is the address where the instruction will be located in memory. That's what that means. So if you look at any of those lines of code there, if I just back that up real quick here, all those lines of code there are referring to where is this coming from in memory. So when you look at the LC3, when we look at the simulator, you know, it just says like line 3000, 3001, 3002. This is where it's storing those lines of instructions. So you can see this one is going from 3000 all the way down to 3009. Right. 6680 is the hex value of the instruction. So if I wanted to know what that is in hex, that would be the hex value. The next line, of course, is the binary instruction of that same code. So we actually with assembly, it will have the hex and the binary. If we continue to analyze it, we have that parentheses 6. And what this means is that this instruction is the 6th line of the assembly language program. Now, it will actually be the 5th line of the program since it gets loaded into the memory of the simulator. But since the line marked 1 specifies the starting location, and we're counting assembly language, not memory locations, this is the 6th line. So when we look at the simulator, remember that starts at line 3000, that's technically line 1. And it goes, and this one is going to be at line 3004. Which means that would be the 5th line in the simulator, because it's line 3004. So 3000, 3001, 3002, 3003, 3004, 3005 would be then line 6. But this is not line 6. This is line 5, 3004. It's 6 because if you remember looking at that assembler line here, let me just pull that up quick. You can see that this right here is at line 6 because it doesn't start technically at 0, because line 1 is just loading up the program. Where it actually starts is over here at line 2. So that's the reason for that. Now loop, that's our label that we have associated with that. That means it's going to literally loop the code until the conditions are met. And then we have LDR, R3, R2, #0. All right, this is the assembly language version of the instruction. So we saw the hex, we saw the binary. This is the assembly language version. And you can notice that the comments that we put in after the instruction are gone. All right, these are only really there for our own or other programmers' information. The simulator really doesn't care about comments. So it really just kind of throws them out when it does its work. All right, and that concludes our notes, folks, for this time. Next time when we come back, we will be discussing how to actually use the simulator.